Hello students, welcome to our second lesson in the second phase of the series in chemistry, Lecture 10. Our subtopic of discussion today is electrolysis of binary electrolytes, and my name is Mr. Situma. Now the objective of the lesson is that at the end of it all, the learner should be in a position to explain the electrolysis of binary electrolytes using specific examples. The learner should be in a position to explain the electrolysis of binary electrolytes using specific examples. Now, if we talk about, or when we talk about binary electrolytes, we are looking at electrolytes that contain only two ions. The word bi means two. So it means this is an electrolyte that has got only two ions. These two ions are either, we have a positive ion and we have negative ion. Just one positive ion and one negative ion. That's why it's known as a binary electrolyte. Now that also means that you have some other electrolytes that might have more than two ions. We shall be looking at that in our chapters later on as we continue discussions. So for today, we are only focusing on an electrolyte that has only two ions. Now, the ionic compounds, when heated, the bonds break. And the breaking down of the bonds means that the atoms which were held together will be set apart. When the atoms are set apart, or when the atoms are broken up, the ions are set free to move. What we're trying to imply is that the binary electrolyte mostly comes from the ionic compounds in molten state. That means when you heat up the ionic compound, then the atoms which are inside the ion break up, and when they break up they form the ions. These ions are the ones that move very freely. So it is referred to as an electron because of the presence of the ions, which will be moving very freely. It is the ions which are free to move that are able to carry electric current forward. But for us to be able to study the passage of an electric current and the decomposition of the ionic compound using the current, we need to understand that we have what we call the electrolytic cell. The electrolytic cell is the apparatus where the entire process of electrolysis occurs. This is the one that supplies the direct current to, it supplies the current inside the system. The direct current supplied by a battery inside the electrolytic cell. It is the source of that particular current that makes the entire process of electrolysis to be possible. Which means that we are looking at a process in which electric current leads to the decomposition of a substance in the formation of new products. Don't forget that we are still looking at chemical reactions. We have looked at different types of chemical reactions. So one of those reactions is the one we are looking at today under electrolysis. Now in the electrolytic cell, we have graphite, which is chosen as the electrodes. When we talk of the electrolytic cell, we are looking at this type of a setup placed in the electrolyte, which is in molten state. That is the electrolyte, and then these are the electrodes we're talking about. That is electrode and electrode. So the electrodes are mostly made of graphite. The reason is because this graphite is unreactive under normal conditions. and is also cheap to purchase. It's not very costly as compared to the other different types of electrolytes, electrodes. Now, when you talk of graphite being unreactive, then we are referring to a situation where the electrode cannot react with the components of electrolysis. That is, it cannot react with the electrolyte, nor can it react with the products of electricity, of electrolysis. I want to listen very carefully, that when you say an electrode is inert, then we are referring to an electrode that cannot react with the products which are formed at such an electrode, or an electrode which cannot react with the electrolyte itself. In this case, we have graphite put in the electrolyte. So this graphite cannot react with the electrolyte, nor the products which are going to be formed around the electrode. So that's the reason why graphite is mostly preferred as an electrode. It's quite cheap and also does not react with the electrode, the electrolyte. The electrons flow from the negative terminal, which is the cathode, the positive electrode, which is the anode in the electrochemical cell. If I may use my diagram here to show how the electrons flow. We have the electrodes placed in electrolytes. Then we have a connecting wire which goes to the source of power. And then there is a sensor. It's either a voltmeter or a galvanometer, or sometimes use a bulb, the normal bulb, such that we have this part of the cell being the positive side, and then this other part of the cell being the negative side. So we're saying that the electrons flow from the cathode. The cathode is the negative electrode. That's the term we use to refer to the negative electrode in an electrochemical cell. So that means that the electrons will be flowing from the cathode towards the anode. So if this is the negative, that will be the cathode, and then this will be the anode. So that's the anode, and then that's the cathode. So electrons will be flowing this side, and then the current, on the other hand, will be flowing against the flow of electrons. When the electrons are flowing this other side, the current will be moving the opposite direction. That's what normally happens. So the electrons will flow from the cathode towards the anode. There is a significance that comes with that. There is some significance that comes with that. When these electrons go on to accumulate around the anode, they make the anode be slightly negative. That's what causes what we call development of a potential difference. Potential difference develops when we have two oppositely charged sections separated by a medium. In this case, the medium is the electrolyte. So we have inside the electrode, we have the charged particles, and we have the electrons accumulating on the electrode. Now let's look at a case. Example, electrolysis of molten zinc chloride. We want to look at exactly what normally happens. A simple electrolytic cell on this particular case, we have the two electrodes. We have this particular electrode which is there, cathode, and we have the anode on this other side. So during the electrolysis, because this is the cathode, this is a negative electrode, and this is the anode, that's the positive electrode, the ions inside the electrode, the electrolyte, will be attracted to the oppositely charged poles. That means that the positively charged ions, that is zinc ions, are going to be attracted towards the cathode, which is the negative terminal. Don't forget the law of science. Opposite charges will always attract. So, the zinc ions which are positively charged are going to be attracted to the cathode, which is the negative terminal. And on the other hand, from inside, the electrolyte, in this case the electrolyte is zinc chloride, the chloride ions will be attracted towards the anode because the anode is the positive terminal. So these two will quickly move apart. Now, I want to bring in the concept of electrolysis in this case. What we had at the beginning is zinc chloride as a salt. Zinc chloride. But after passage of an electric current, once it starts passing through, then automatically the zinc chloride that we had at the beginning decomposes immediately because after heating the ions are free to move. So upon heating, we have zinc ions which are going to be formed and chloride ions which will be formed as well. So these two ions mark the beginning of the process of electrolysis. Remember that this is the decomposition of an ionic compound by the passage of an electric current. When we talk about binary electrolyte, then the electrolysis process is the decomposition of an